Okay, the Cartesian plane is determined by two perpendicular number lines called the x and y axis, and they intersect at the origin. So that's what we've been doing before, right? Where we just have the x-axis, well, this way, and the y-axis, and that was it. Now what we're going to do is some three-dimensional stuff. So that Cartesian plane allowed you to have two-dimensional coordinate systems for identifying points in a plane. In order to identify a point in space, you're going to have to introduce a third dimension. So what the third dimension does is it like comes out at you, okay? So what you're kind of treating this as when you look at this graph paper, this is the x-axis going this way, and this is the y-axis. So think of that like the table, okay? The x-axis is coming to you, the y-axis is going across this way, and then the z-axis is doing what? Going up out of the table. Okay, so now we're in 3 dimensions. So if we're given a point in 3 dimensions, you would go, like for this, you'd go 2 on the x-axis, so we come 2 towards me. Negative 3 on the y would be 3 to the left on the y, and then this 3 in the back means you go up 3 units. So it's hanging out up here above, like the table, kind of a thing. Do you have questions on that? Okay, so highlighting a couple things, we're obviously introducing a third dimension. And it's called solid analytic geometry. You don't need to highlight it, it's already underlined. Okay, it says the three-dimensional coordinate system is constructed by adding a z-axis perpendicular to the x and y. Taken in pairs, the axes determine 3 coordinate planes. So you have your xy plane. What is a plane? Something flat, right? So for this, if we're talking about the xy plane, our plane would be like the table going on forever in every direction, okay? If we're trying to find what the yz plane is, this is y and this is z, so that would be like, if here's my y-axis and my z-axis comes up, it would just be like a plane that would be like this, going on forever, okay? And then the last one, the xz plane, would be the one that goes with the x-axis and the z and would go on forever, going like straight up and down, okay? Okay, so a point is determined by an ordered triple, so instead of just like 2, 3, it might be 2, 3, 1, and you have to plot that. So we're going to go ahead and find this point, 2, -3, 3. And the first thing you can do is find where 2, 3 would, or 2, -3 would be on the x and y, and then just move it up or down depending on your z value there. Okay, so if we're trying to do 2, -3, 3, you're going 2 on your x and -3 on your y, so let's just start with that. So 2 on the x means we're coming 2 out. So this is our x-axis, you come 2 towards you. And -3 on the y means you're going -3 or 3 to the left. So what I usually do when I do that is I draw this so it looks like a parallelogram. Draw this so it's parallel to this, and draw this so it's parallel to the y. And then that would be the point 2, -3. Okay? And then what you need to do is you need to go up 3 units. So do you see how 3 units is, let me grab a little cheater here. So 3 units is like this long, isn't it? So that's how tall that should be. Okay? And this length here is how long, you know, this part should be, and this length here is how long that part should be. So I usually just make all the pieces dotted and then plot the point because it's a little bit easier to see where it's at then. So if we try point P here, we're going to have to go by 2's because this graph paper only goes up to 4 and that goes to 5. So let's do everything by 2's. Scale by 2's, we'll just say. So for the first one, we're doing 2, and that means I'm doing what? I'm coming out 2 towards me, so that would be like this here. And then I'm going to the right 5, and to the right 5 would be like that, right? So I'm going by 2's. So what I'm going to do is take those usually, whoops, that's not what I wanted to do. Take those and I make them dotted typically. And I'm just going to make a parallelogram out of them. And then I need to still do what with it? Go up. How much? Yeah, half of a piece here because it's up 1. So then you'd take that length and that should go up from where this was. So it looks like it lands right on the y-axis. So this would be point P here. So questions on that? Okay, so let's try Q. So Q, we're going to do the same idea here. I'm just going to switch it to a different color. I suppose I could make it dotted here. Okay, so for Q, we are going out 4, so towards us 4. Keeps moving that. There we go. Okay, so coming out towards us 4, and then we go to the right or left, how many? None, right? Because it's 0. And then we're going, yeah, down 5. So 5 would be this much. And I'm going to connect that to where it was on the X and Y, maybe. It likes to move that. There it goes. Okay, so then it ends up down here. The big thing is, this should be parallel to the z-axis, this should be parallel to the x-axis, and this last piece would be parallel to the y-axis. This is 5 down because it was 2, 4, 5. That's the same length. It's like a diagonal, remember? Like if I connected, it might help you if I moved this point down. That's why it's kind of hard in the 3 dimensions because you're kind of at a weird angle and stuff sometimes. Oh man, I didn't mean to do that. Oh well, we'll just keep moving it. So this was at like that 5 down. And do you see how that creates like a parallelogram look there? Okay. What? Oh, okay, good. Okay, so questions on P or Q? Okay, the last one here is R. So let's just do that in a different color. So let's go with a yellow or something here. Okay, so last one, the -2 means I'm going, back, right? So I'm going back 2 units. And then I'm going to left 4. So going to left 4 is this much. And that's from here. And then I'm going up 3. So going up 3 would be like 1.5 of these. And then I connect that to where it was in the XY plane. Okay, so this would be the point R there. So questions? If it's realistic. Okay, so questions on that? Just, trying to get things so that they're parallel. Kind of like when you draw a 3D shape, you always try to get the pieces so they're parallel to the other pieces so they look right. Okay, let's go to the next page. Okay, distance formula and midpoint formula are actually, and even the equation for a sphere over here, they're very, very similar to the 2-dimension equations. Okay, if we're trying to do the distance formula here, wasn't the distance formula in 2-dimensional space just this part up here? You do the change in x's, you square it, you do the change in y's, you square it, and then you square root it. All you have to do is just do the change in z's and square it in the back, okay? So if we're trying to find this distance, I'm going to kind of shorten it up here. How much do my x's change by? 2. What happens when I square that? I get 4. How much did my y's change by? 2, and when I square it, I get 4. How much did my z's change by? 4, when I square it? 16. And that's how quick this is. So I get the square root of 24. And does that break down? 2 square root of 6? Because it's square root of 4 times square root of 6, right? So that's 2 square root of 6. So any questions on that? And if you have to write it all out, you can, but I just think it's, a lot quicker and simpler just to find the changes and square them right away. Okay, midpoint formula. If you remember midpoint formula before, you just averaged your x's, averaged your y's, so all you have to add into the back is averaging your z values. So if I take my x's and I average them, I just add them up. So if I add them up, I get 3 and -8, and I divide it by 2. The next one, I get -2 and 6, and I divide by 2. And the last one, I take 0 and -4, and I divide by 2. So what do I get for my midpoint here? So -5/2, or -2.5 if you want. This one is 2, and then the last one is -2. So any questions on distance or midpoint? I don't think we need to sit on it for long or anything. Yeah, pretty much the same as it was before, or what you'd kind of expect, right? Okay, now equation of a sphere. Okay, so when you think about the equation of a circle, the equation of a sphere is going to be very similar to it, but it brings that, z dimension into it, that third dimension. So a sphere, the set of all points such that the distance and the fixed point is constant. So if you think about having, let's say, a piece of string or a ruler or something like that, and let's say this is, we have the center just somewhere in space. Okay, a sphere is a combination of all of the points that are equidistant from that center. That's how like a ball is made, right? They would all be the same distance from the very center of the ball. That's the same thing as like a circle, right? But circle's just in 2 dimensions. Everything's like the same distance from just that center. Okay, sphere just ends up, going every single direction. Okay, so that's all that's saying up here at the top. And if you guys remember the equation for a circle looked like this, didn't it? Okay, you do your x minus h and you square it, plus your y minus k and you square it, and that equals r squared. So all you have to add into here is z minus whatever the z coordinate is. Okay, so that hasn't changed very much. And we're going to use that for the next page and note. So any questions before we flip it? Okay. So find the standard equation whose center is this. So what do I do with the 4? X minus 4. And one way to think about it is, how do I get this back to 0, 0, 0? What do I have to do with the x? I have to subtract 4 from it. So that I know helps some people, and then you square it. Plus, and then what do I do with the y? Subtract 3 from it and square it, plus z minus 2 squared, and then equals, and then you do your radius squared, which would be 25. That's it. Okay, that's your equation. Okay, find an equation of the sphere that has these points as endpoints of a diameter. So if I put, a diameter through the center there, these would be endpoints. So can I do what I did here and just use one of these points, or what do I need first? You need the midpoint in order to get your center, right? So let's go ahead and find what the midpoint is. So let's write here, the midpoint is equal to the center. So I'm going to say the center is, if I add up -2 and 4, what do I get? 2 divided by 2, 1. If I add up 5 and 1, I get 6 divided by 2, 3. And 7 and negative 3 give me 4 divided by 2, 2. Okay, so we have our center now. What's the other thing that I need? Radius. How could I find my radius if I know the center? Okay, so if I find the distance between the center and either of these, I should get the distance of my radius piece, right? So if I'm doing distance, which point do you want to use? Second one? Okay, so we'll use this point and this point, the center, and we're going to find the distance between them. So the distance is going to give me my radius. So the distance formula, how much do my x's change by? I'm going to write r equals instead of d equals. That way it's not confusing on what this is giving us. So my x's change by 3. When I square it, I get 9. Okay, so you do the change in x's, we square it. The y's change by how much? 2. When I square it, I get 4. And my z's change by how much? 5. When I square it, I get 25. So 9, 4, and 25 gives me, so this is square root of 38. Don't try to clean this up. Sometimes, you'd be like, oh, I'm going to try to make this a simplified radical. What are you going to do when you write the equation? You're going to square it, so it's just going to be 38. So you don't, otherwise you're kind of making more work for yourself. So if I'm trying to write my equation, I use the center and I use the radius. So I don't really need these points anymore here. So my center is 1, 3, 2, so that's going to make my first parenthesis x minus 1 squared. The second parenthesis, y minus 3 squared, and the third, z minus 2 squared. And then it equals r squared, which is 38. So that's your equation. Any questions? Okay, now this one, we did this before just without the z's. You're probably going to need a little review of even how to do it, even if we didn't have the z's in there. This is where we do our completing the square. Okay, it's really not that difficult. Okay, so what we're going to do first is put our x's together. So I've got x squared plus 6x, and then I just leave a blank in the back. Okay, you're going to do that with each of the letters here. So that's just my x piece. So let's do that with the y's. So my y squared goes with minus 8y, and then I just leave a plus blank. And then the z's, you do the same way. So z squared plus 2z, and then plus blank. And then what do I do with that negative 10? Do you guys remember? Move it over. So if I move it to the other side, it turns into positive 10. Now, if you remember, anything I add to the left-hand side, I also have to add to the right-hand side. So I have a plus blank here, here, and here, so I'm going to have 3 of them here. So I'm just going to add those into my spot here. And now going into this spot, this is my b value, right? The linear piece there. So to come up with what goes in here, you do b over 2 and we square it. Okay. So my b here is 6. If I do 6 over 2, I get 3. When I square it, I get 9. So if I added 9 here, I have to add 9 here. So go ahead and find what goes in those other spots there. Okay, so you'll use the negative 8 and the 2 and just do the b over 2 squared and put them in there. Okay, so what goes in the blank for the y? 16. So then 16 goes here. And then in for the z would be 1, so then you add 1 over here. So questions on that at all? Then I have to actually complete the square. So when I'm completing the square, it's what adds to here and multiplies to here. And it's going to turn, it should be the same number twice. So what adds to there and multiplies to there? 3 and 3. So it'd just be x plus 3 quantity squared. And another way to come up with this, if you're, kind of poor at doing those type of things, this is just the b over 2. Okay, whatever's in this parenthesis is what you put in that spot. Do you see how 6 over 2 gives you that 3? And that might help you with the sign so you don't mess up a plus or a minus there. Now the y, if I do b over 2, what do I get? Negative 4. So just be careful you have the positives and negatives correct. And then the z is going to be plus 1. Good. And then equals 10, 9, 16, and 1 gives me 36. So if it asked for the equation, we would be done now, wouldn't we? What does it ask for? Center and radius. So my center is what? Opposite of all those. So negative 3, 4, and negative 1. And then my radius is what? 6. Because it's the square root of that, because that's your r squared. So questions at all? It's really not that bad, right? Okay. Now the last page seems complex again, but it's really not to actually do the solving here. Okay, so trace of a surface. A trace of a surface is the intersection of the surface with one of the 3 coordinate planes or a plane parallel to one of the 3 coordinate planes, but typically just like the xy plane or xz or yz. So what that's saying is, let's say I have this plane, this piece of paper here, okay? This table is my xy plane. If this piece of paper at, this particular angle, it's going to eventually intersect this table, isn't it, if it goes on forever? Okay, what kind of a, not shape, but what kind of figure is it going to cause when these intersect each other? If it was like highlighted where they intersected, wouldn't it be like a line? Just like here where they intersect, and it would go on forever, right? So that's what the trace is. That trace of a surface would just be the line. It's where they intersect and all the spots that they intersect. So they intersect at an infinite number of points, right? But it forms a line. Let's say I take a ball, okay? And if for some reason this ball has superpowers and can go like through the table. So let's say I put the ball partway through the table. What kind of a shape is that going to have? A circle, right? Because it's going to intersect like in that circular piece. So the trace of that, of a sphere and a plane, would be like a circle, okay? Is that kind of making sense? Okay? So let's try this. It's really easy to actually come up with them. I just like to have you have an idea of what you're actually doing here. So the xy trace of a surface consists of all points that are common to both the xy plane and the surface. So if we think about trying to find when something intersects the x and y surface, what is the z value when it's hitting the xy plane? 0. So all you have to do is plug 0 in for z, and then solve, and you're done. Okay, so if we were trying to find the yz trace, what would you do? Plug 0 in for x. Okay, so you plug 0 in for whichever one you're not finding, okay? So the xy trace consists of all points common to the xy plane. To be part of the xy trace, the z coordinate has to be 0, we said, right? Okay, so for this one, find the equation of the yz trace. So what am I going to do if I'm trying to find the yz trace? Yeah, the x has to be 0, so that might be something you want to write here. The x coordinate must be 0. Okay, so all you do is you plug 0 in for x. So I'm just going to write it out. This would be 0 plus 1 squared. This other stuff doesn't change. And I'm just going to write this as 25. And so this just turns into what? 1. So I'm just going to subtract the 1 over. So you just have y minus 2 squared plus Z plus 3 squared equals 24. Okay, what kind of a figure was this, just looking at the rule? This was a sphere, right? And it says of the sphere, right? So we started with a sphere, and it intersected the YZ axis. What does this look like? A circle. So does that make sense? And this is your answer. You're done. Okay. Cool. So then there's your homework.